All right, hi guys. This lesson is on combining like terms. We use this method to simplify expressions to try and make them easier for us to possibly evaluate or at least to look at so that we don't have so many complicated variables all in one expression. So we're going to look at combining like terms and look at what that actually means. And in order to combine like terms, we need to know what terms are, and then what like terms are, and then how to combine them. You got it. So let's talk about this one right here first. 1 plus 2. If you have things being added, okay, the things that you are adding are called terms. 1 and 2 right here are both terms. Really important that they're being added. That doesn't work for multiplying. It's just when you're adding. So 1 and 2 are terms. So can you point out to me the terms on this particular expression right here? What 3 things are being added together? The 2x is one term. The 3xyz squared is one term. And the 92 is another term. So all 3 of those are terms. So you can have 2 terms, you can have more than 2 terms, depends on how many things you're adding up. All right, a couple more vocab words for us. If we have this particular term right here, 2x, I'm going to zoom in a little bit. Okay, we've got 2x, and that means, we know that means 2 times x, right? It also means you can think about it as there's 2 x's. If there's a number in front of it right there, the number in front of the variable, that too, has a name. It's called a, let you guys see this in writing, a coefficient. Coefficient. Has anybody heard that before? Coefficient. Okay, we're going to put what this is so we remember later. It is the number in front of a variable. It basically tells us how many variables there are. There's 2 x's, or 2 times x. So the 2, the coefficient, tells us how many variables we have. Okay, what's the coefficient for this term right here? 3xyz squared. The coefficient would be 3. It tells us how many of all those there are. All right, what about this one? Do we have a coefficient right here, 92? No, there's no coefficient because there's no variable. The coefficient has to be in front of a variable. But this has another name. We call a term that is just a number, a constant term. Have you heard that before, a constant in math? I know you've used them in science before, something that remains the same in an experiment. Okay, a constant term is one with no variable. So you have 2 C words here that you need to remember. Coefficient, the number in front of a variable, and the constant term. And that's a term with no variable in it. Okay, now that we know these words, let's see how we can use them to talk about like terms. These are terms. Let's see what like terms are. Move this down and over a little bit. Maybe I'll zoom out so you can see the whole thing. All right, like terms. If you have like terms, here's what they have. They have the exact same variables. Like terms have the exact same variables. Now that could also mean that they have no variables in them. If you've got terms with no variables at all, that means they have the exact same variables. There's just none of them. So the exact same variables are considered like terms. They're similar to each other because they've got the same variables. And it turns out, if we have like terms, guess what we can do with them? We can combine them if they are like terms. So if they've got the same variable, we can combine them together. We can actually add them together. I'm going to move down and let's do some examples of this. Let's see if you guys can handle it. All right, going down. This first example, 2y plus 8y. I think about it as 2y's plus 8y's. Okay? Are they like terms? In this term and in this term, do they have exactly the same variable? Yes, they both have a y. So can we combine them? And the way you think about it is 2y's plus 8y's is how many y's? What's 2 plus 8? 10, and it's still a y. So 2y's and 8y's gives you 10y's. You get to add up those coefficients, and you get to keep the variable by itself. All right, over here, let's look at this like term. Is it a like term? We've got 3y's plus 4xy's. Are they like terms? Do they have exactly the same variable? No, this one's got a y and this one's got an xy. So even though they both have y's, they're not exactly the same. We can't combine them. We can't do anything with that. We would just keep it the same. We can't simplify it at all. That would be our simplified expression. All right, let's try down here. I'm going to zoom in, move down. Give it a second to focus. Come on, come on. All right, example 3 over here. We've got a whole bunch of e's, b's, e's. Okay. We need to look at this and we want to say, hey, can we combine like terms? Well, first of all, do we have terms that we're looking at? What we want them to be is things that are added together. Okay, do we have adding going on here yet? No, we don't. So we can't do anything yet. However, do you guys know how to change the subtraction to adding the opposite? Absolutely. Can we do that? If you change subtraction to adding the opposite plus a negative 2b, instead of minus 4e, it would be adding the opposite, which is negative 4e. Okay. And I'm going to write that down here just so that you can see. You could actually rewrite it, and I'll put in the parentheses just to separate it a little bit. It's a little bit easier to see that way. Okay, I'm going to zoom in a little bit more now, and we'll just focus on one at a time. All right, now we want to look. Do we have like terms? Come on, focus. You can do it. Here we go. All right, do we have like terms? E, is that the same thing as B? No. So E's and B's we can't combine. What about this E and this E? Are they exactly the same variables? Yeah, so that means we can combine this one and this one. So negative 7e's plus negative 4e's. Negative 7 plus a negative 4 gets more negative, takes us down to negative 11e's. So those two get combined. What about these plus negative 2b's? What do we do with them? Nothing. We just bring them right down. Copy them down again. We haven't used them. And at that point, can we combine e's and b's here? No, they're not the same variable, so we're done. That's as much as we can do to combine like terms there. Okay, let's look at example 4. This one we've got x plus 2x. All right, are they like terms? Does that have exactly the same variable as that one? Yeah, x and x, cool. So let's combine them. All right, so that means we just add up the numbers. Well, what's the coefficient for this guy? There's nothing in front of it. So how do we know how many x's there are? Well, there's just one x there, right? Isn't that the same thing as saying this? 1x? The coefficient's really just 1, even though it doesn't show that on there. There's just one of them. So 1x plus 2x's gives us 3x's and done. We combine those like terms. All right, let's flip the page. Let's see if we can do a couple more complicated ones, and then you'll try some on your own. All right, flip over. Oh, we can kind of see through there. Let me get a clean copy. And go ahead and look at example 5. This one right here. Before we can combine like terms, what do we need to change that subtraction into? Adding the opposite. So plus a positive 2b. All right. Are we allowed to combine b's and b's? Sure. So let's combine them together. Now, we have this other situation here where this one does not have a number out in front. There's no coefficient. It's just negative b. Well, how many does that really mean there are? That's just like negative 1b. Negative 1b's. If there's a negative there, there's still just one of them, but it's negative 1. So can you guys do negative 1 plus positive 2? What's negative 1 plus 2? Positive 1. So you get 1b. Kind of looks like an L there, doesn't it? 1b, or could we just say b? Do we really have to have a 1 in front of it? No, there's just one of them there. You could just have b as your final answer for that. That's as simplified as we can get it. All right, let's look at example 6. Whoa, here's where it starts to look a little bit crazy. It really isn't. The first thing you've got to ask yourself, is it all addition? Is it all addition yet? And if it's not all addition, can we change it to all addition? So let's do that. Let's change this. Let's get a different color here. That's addition, good. This one, to change it to adding the opposite. we add a negative 2ab. This one, we add a positive 4a. We're adding the opposite. Is it all adding now? Yep. Okay, so let's see which ones we can combine here. We need to combine terms that have exactly the same variable. So looking at this first one, negative 5ab's, is there any other that are just ab? This ab, here's an ab. Can we combine them? I'm going to put a box around those ab's. This negative 5b's plus negative 2ab's. And I'm going to say I'm going to combine those guys. Okay, negative 5 plus negative 2 gets more negative. That's going to take us down to negative 7ab's, right? All right, let's look at the rest of these. Here's a b squared. Are there any other b squareds we can combine it with? That's an a, that's a b, there's a b squared down at the end. So a b squared and a b squared get to combine. Is a b squared the same thing as a b? No. B squared and b are different variables, so you cannot combine those. But we can combine b squareds and b squareds. So let's do, maybe I'll put a circle around this. The 3b squared plus the negative 2b squareds. 3 plus negative 2 takes me down to what? 1. So 1b squared, or just b squared. And then what do we have left over here? We've got 4 a's and we've got a b. Can I combine those? Oh, a and b aren't the same variable. They're not like terms, so guess what? I just copy them down. And I'm done. I've got ab's, b squareds, a's and b's. I can't combine any of those because they're not exactly the same variable. So I'm done. Okay. Let's look at 7. Is it all addition? Addition, 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 addition. Sweet. I don't have to deal with that step. Let's look at what I can combine. I see some xy's. Where else do I have xy's? xy, xy. I'm going to put a box around all those xy's. 2xy's plus 6xy's plus 3xy's. Can I combine all of those right now? They're easy enough. I think I can do all 3 of them. 2 plus 6 is 8, plus 3 is 11xy's. Okay, and those are different from the x's. This x and this x are the same, so can we combine those? Maybe I'll circle those guys so it distinguishes them from the xy's. 7x plus negative 3x. That gives me 4 x's. And they're still adding everything together, so I put my plus in between. And can I put xy's and x's together? Nope, not the exact same variable. Not like terms, so we're done. All right, last one. Keep that at the top for a second. First of all, can you go through and change all the subtraction to adding the opposite? Let's do that real quick. We can't do anything until we're talking about all addition here. So this would be plus a negative 4z. This one here would be plus a positive 5. Now we'll move this up, and let's see what we can combine. Z's. I see z's. I see z's. I see z's. Those are all the z's I have. Can I put those together? 3 plus negative 4 would be negative 1. Plus negative 7 would be negative 8 z's. This one would be, let's see, this is a 5. What's that term called again when it's just a number and no variable? What's that called? That number is called a constant term. Are there any other constants besides just this plus 5? So plus 5, and what about this guy? Isn't that constant also? Could I combine those? Are they like terms? Can I add 5 and negative 2 together? Sure, we've always been able to do that. Just 5 plus negative 2. That's going to be 3. And then I have this lonely old j by itself sitting there. It can't combine with anything else. It just gets brought down as a j. We can't combine anything else there, so we're done. All right, let's let you try some on your own.